And we can find the Fourier series coefficients 1 upon t naught integration over t naught xt e to the power minus j k omega naught t dt. Okay, this is the Fourier series analysis and synthesis equation. Now first let us discuss the differentiation property. If xt Fourier series, what about the derivative of that? First of all, will it be a periodic signal x dash t? If xt is periodic, what about x naught t? X dash t? Will it be a periodic signal?
Yes, sir.
If it is a periodic signal, then only this Fourier representation makes sense.
Yes, sir.
The derivative of a periodic signal is always periodic, and it is fundamental period will remain the same. So we can find a Fourier series representation with respect to the same period. Let me denote it by bk. And can you tell me what is the relation between this? This is xt, isn't it? So this is xt. If you differentiate both sides of this equation, the Fourier series synthesis equation with respect to t, then we will get this relation x dash t is equal to minus k ak e to the power, sorry, it is j k omega naught into e to the power j k omega naught t, isn't it? I'm differentiating both sides of this Fourier series synthesis equation with respect to t. This is xt is equal to this summation. That is the Fourier series synthesis equation. So we'll get this relation. Now tell me what is bk?
AK JK omega
It
omega
is
naught.
ak into jk omega naught, isn't it? Is it this? Because this is the summation, this x dash t in terms of this complex exponential. So comparing with the Fourier series synthesis equation, you can find that these are the Fourier series coefficients of the signal x dash t. Okay. Now can we generalize this? If we take the nth derivative of, then what will happen? Differentiate both sides of this equation with respect to 2. Yeah, find the nth derivative of this. What is this on the right hand side?
AK JK omega naught to the
jk
power
omega
n.
e to the power jk omega naught t. Okay, so we have proved the differentiation property. The differentiation property, so we can generalize this. The differentiation property says that if xt Fourier series with respect to period t naught ak, then if you consider the nth derivative, its Fourier series with respect to the same period, that is ak into jk omega naught. Okay. So that is the differentiation property. Now what will be, okay, I'm writing it as bk. What will be b0? B0?
0.
B0 is always 0, isn't it? B0 is always 0?
Yes, sir.
Because whatever be the value of ak, it is multiplied with jk omega naught, isn't it? If you are taking the first derivative. Otherwise, it is jk omega naught whole to the power n. So this b0 is always 0. And it makes sense also, isn't it? Because when you differentiate a signal, you will lose the information about what? The average value of the signal, the average value of the signal be 0? If you differentiate a signal. Okay, let me take an example. Consider this one you have already discussed, seen this standard result 0 t1 minus t1. Let's say this is t naught. What is the derivative of this? What is the derivative? Derivative of this rectangular pulse train. This is rectangular pulse train. What is the derivative of this?
0 throughout.
Is it 0 throughout? Or what about this discontinuity?
Delta function.
There is a delta function, isn't it? So is this the derivative? This one? Why this one? What is the area under this impulse? Remember, whenever you differentiate a function that is having step continuity, you will get a delta function. And the strength of that delta function is equal to what? Strength of the delta function.
So the jump in the discontinuity.
That is the height of this jump, isn't it? This height in this at that point. So here the height is 1. And what about this? This is a jump from 1 to 0. So the height is -1, isn't it? That is related to unit step function. What is the derivative of unit step function? Is it a unit impulse? Derivative of unit step function. It is a unit impulse, right? And if you would multiply with -1, you can see that it's an impulse of strength -1. And what is the average value of this signal? This is the derivative. This is, let's say, this is xt. This is x dash t. What is the average value of this signal? How to find the average value of the signal? Where is T naught? Sorry, this is T naught, right? T naught 0, and this is T1, and this is minus. Oh, sorry, there is something wrong here. This is T1. Let me draw it here. This is, there is an impulse here, impulse here. Then there is one here. Tell me, what is the average value of this signal? How to find the average value of a periodic signal? You integrate it over one period, and then what? What is the average value of any signal xt? How to find if it is periodic with period t naught? What is the average value of the signal?
So integrate over the time period T naught upon T naught.
Integrate over one period and then divide by t naught. You will get the average value of the signal. Now, what is the average value of this signal?
0.
It is 0. The average value of the signal is 0. So can we say that if you differentiate any periodic signal, the average value is always 0? Is it? If you are given any periodic signal, let me explain that. If you are given, let us consider this example. Now, what will happen if you add a constant value to this signal? What will happen? If you are that is a DC shift, isn't it? If you add a constant value to the signal, it will be shifted up or down, is it? Depending on if k is positive, let's take c. If c is positive, it is shifted up, and if t is negative, c is negative, it is shifted down. That is DC shift. Is it?
Yes, sir.
Yes, sir.
Yes. Now, if you differentiate this signal, if you add a constant value and differentiate this, will you always get this?
Yes, sir.
Yes, sir.
We'll always get this. But what is the reason? Because we can write. Can we write this signal as as something having 0 average value? Can we make the DC value of the signal 0? xt. How to make the DC value? What is the DC value of this signal? xt. This is T1, T naught is the period. What is the DC value of the signal? If you consider one period from minus T naught by 2 to t naught by 2. What is the average value of the signal? I'm asking. Sorry, it is 2t1 by
Not.
t naught. Okay. And how to make this average value of the signal 0? I want to make the average value of the signal xt 0. Forget about this constant term now. How to make that? Its average value is 2t1 by t naught. How to make the average value 0?
So DC shift downward by some.
DC shift downward by, will you get a
Some-
signal like this? Is it something like this? If you DC shift, if you apply DC shift to make it 0 average value, and what is the height then? This one is what?
Minus 2t1 by 2.
Minus 2t1 by. This is original amplitude is 1. You are shifting down by 2t1 by t naught. What is this? 1 minus 2t1 by t naught, isn't it? This one is 1. You are shifting it down by 2t1 by t naught. Then what is the this value amplitude, my peak amplitude of that signal? Is it 1 minus 2t1 minus t naught?
Yes, sir.
That is the signal. So can we say that this is a signal having 0 average value? Now if you apply a DC shift, you will get, depending on, if you add a constant value to this signal, you will get a periodic signal that is having some DC value. It is shifted up or down with respect to C. And depending on the value of C, there are infinite number of such signals, isn't it? Only difference is that the difference is in the DC value only. Now, if you differentiate any such signal, will you get this?
Yes, sir.
We'll get this. Because if you can use the linearity property of differentiation. If you differentiate this, the constant term, it is a zero mean signal plus a constant term, and this constant derivative of that constant will be always be 0. Okay.